All right. So without any further ado, I'm just going to share my screen and take you through the presentation. Can everybody see the screen?
Yep, we're good. Thank you.
All right. So let's get started with the presentation first. And as you can see, today's title is just asynchronous JavaScripts and JavaScript and promises. And the goal here to understand is that how JavaScript would handle tasks that take time. Like it could be fetching data or reading files without freezing the rest of your program. We will explore how promises and async await makes that process cleaner and easier to manage. So in JavaScript, code normally runs line by line, and that's just called synchronous execution. But when an operation takes time, like it could be an API call, it can block everything else. That is where asynchronous programming comes in. It lets other code keep running while we wait for that slow task to finish. And as uh, so here's just one simple example to visualize it at the bottom. In this code, we're just putting up a console log statement that says I'm creating number one. And then there is a function that's called set timeout, which appears in the middle. And even though it appears in the middle, JavaScript wouldn't wait. It would actually move on and execute this line of code right away that says I'm greeting two. And then after 10 seconds, this console log statement will be executed. So that is one brief example of how asynchronous behavior uh, allows us to keep the code running while the delayed task happens in the background. So this is part of what keeps web pages responsive instead of freezing. And then there's the traditional, earlier we used to handle this before promises came along. JavaScript handled asynchronous operations using callbacks. A callback is simply a function passed into another function to be executed later. So, for example, whenever an event happens or when the data finishes loading from the fetch call, here are some of the issues that could happen. As our code grows, callbacks start nesting inside other callback functions, and you can even see this pattern here. One async call depends upon another and another after that, and this is just creates a really complicated ladder, or what used to be called callback hell. So the problems here were really clear. As the number of calls increase, it become really hard to read and maintain that code. Error handling would get really messy because you would need separate logic at each level, and the control flow, that's just what the order of what happens when, would become really difficult to follow. So we needed a cleaner, more structured way to handle asynchronous operations, and that is where promises come in. So to understand more about promises, let's just try to so what exactly is a promise? In JavaScript, a promise is an object that represents the eventual result of an asynchronous operation, which it is basically a placeholder for a value that isn't available yet. So think of it this way. Let's say that you're waiting on a new on your favorite singer to release a new song, and you're one of the many fans who's just wondering when will they release the new song. And then the singer just tells you that I will put it out as soon as it's ready. So the fans, of course, they want to get the most they want to be aware of that as soon as the song launches. So they subscribe and with their email, and that's using either the then method or the catch method, so that they could get notified as soon as the songs gets released. And when inevitably the song gets ready, everyone gets it automatically. So if something goes wrong, they all would get notified of that particular failure, or they wouldn't get a notification at all. So in programming terms, the producing code is your async operation, like fetching data. The consuming code is what needs that result, and what links between the producing and the consuming code is the promise. And then a promise can be either one of three states. It would be the pending state, which denotes that the operation is still running. The fulfilled state signifies that the promise has completed successfully and it has a result. And there's the rejected state. It obviously denotes that it has failed and it has an error. So once a promise settles, fulfilled or rejected, it would stay that way permanently, and that would lead us to uh, creating creating and using promises. So now that we understand what a promise is conceptually, let's look at how we actually create one in code. So in JavaScript, you can create a promise using the promise constructor. It takes a function which is called an executor, which automatically runs as soon as the promise is created. So the executor function receives two built-in parameters, that is either resolve or reject. So, and here's how it works. So the executor function would run immediately when the promise is created, and then inside that executor function, you will have your async operation that could be fetching the data, or it could be just running some sort of code that would take really longer time, or you would want to run it after some time. And then uh, there's always success handling. If the operation succeeds, you could always call the resolve method to show the particular data that you fetched from the API. And in case of failure, there should always you would always call the reject error. So the example here, we're just fetching the list of fruits, and the get list function returns a promise, and then inside we use the timeout set timeout method to mimic a delay, and after 1 second we call the resolve with an array of fruits. The 1,000 number here represents the number of milliseconds that are there in a second. And usually when we set the timeout, we always set it in milliseconds. So the key idea here is that promise is returned immediately even though the data isn't ready yet, and this would allow the calling code to attach handlers like maybe then or catch and continue running without waiting. Next, let's see how we can extract and use the value from this promise once it's fulfilled. So as I mentioned before, there are we can so once a promise is created and returned, we can handle its result using built-in methods like then and catch. And then is you the then method is used where when the promise is fulfilled. It takes the callback function when that receives the resolve value. So for example, in this particular code snippet here, that shows the list promise then. Uh, this only runs when the promise is successfully resolved. And then there is the catch method. It is particularly used to handle errors. So if the promise is rejected, the callback inside the catch method runs and it receives the error. And there's a one particular example that's below here. And then finally, we can always use the chaining pattern that which combines both methods to handle success and failures for one flow. This particular code snippet has the example. So before I move ahead, I just wanted to see if anybody else has any doubts with what we've discussed so far. Any questions so far? So, if there are no questions, if at any point you find encounter any questions, please feel free to interrupt me and just ask it. So, we'll just move on to this particular slide. Let's try to talk about promise chaining. So, this is actually one of the most powerful feature of promises because it allows us to connect multiple asynchronous operations in sequence without falling back into the callback problems that we see where we had seen with before. So here's how it would work. So each then method would wait for the previous promise to resolve before running, and then the value returned from one then method would be the subsequent input to the next. And then if at any point, if any steps fail, the chain would jump directly to the nearest catch method. So you would only need one centralized error handler. So in this example, the let's see if I can notate this. I did that. I was. Mm, this always feels like. So, in this particular example here, this function delay double, it would return a promise which would double a number right after 1 second, and then and then chain the then method to call it again. The result appears as maybe 10 and 20 and 40. It would appear subsequently, uh, but it would appear like one at a time. So the key takeaway here is that the structure is like flat and readable as compared to the examples that we've seen earlier. Each step is independent, easy to test, and the flow is clear. It's actually a significantly huge improvement over nested callbacks. And then we're going to take a look at one of the other methods that's called finally, and we'll just see how it fits into this pattern. So the finally method is let's talk about the finally method. So this one runs after the promise has settled, meaning it's either fulfilled or it is rejected or yeah. So it's perfect for cleanup tasks that should always happen no matter what the outcome is. So here are some characteristics to remember. The finally callback would not doesn't receive the error. It's only meant for generic cleanup. It's completely transparent. It means it passes the original result or the error through to the next handler. And then anything you return, and then if you return anything from the finally method, it would be ignored unless it throws an error. So some use cases involve UI cleanup, like stopping the buffering buttons once the buffering loop once the video has been loaded, or it could be closing database connections once the user is logged out, and or it could be some resetting the UI defaults, UI states. And then here's one particular example that shows the that is like the basic logic behind the loading spinner. So even if the fetch fails, The spinner still hides the spinner, and finally guarantees that the cleanup code runs every time. So now that we've covered the then, catch, and finally methods, let's just move on to the modern syntax that simplifies all of this, and that's called async await. So async await is one so this it's essentially the syntactic sugar that's built on top of promises, meaning it doesn't really just replace promises, it just makes them easier to read and write. So here's how it would work. The async keyword is placed before a function declaration. It automatically makes that function return a promise, and it allows you to use await inside it. And then the await keyword pauses the function's execution until the promise settles and gives you the result value. So if you take a look at the left side of the slide, that's the old way using the then method. And then you can see there's like a chain of callbacks uh, that can get a bit cluttered if the function's complexity gets expanded. And then on the right side, you can see that there's the async await function of the code. Notice how much cleaner that looks. There's no chaining, there's no nested callbacks. It's simpler handling using the try catch block if yeah, which is like one of the most familiar blocks that you will ever see. And then we'll just see how async await compares directly to promises in a real example, and how it makes sequential operations much easier to follow. So to summarize everything we've covered so far, here are some best practices and key takeaways. uh, Async await should be the default choice for new code and sequential operation, since it's the most modern standard and easiest to read. Try using the then catch methods when you're working with existing promise based code, or when you need to run tasks in parallel using methods like Promise.all. And then you should use callbacks only when the event listeners that you would be implementing are really simple, or if the APIs are like really old. So I would recommend avoiding them for when the logic that you would be building on is really complex. And then some common mistakes: forgetting to add the word async keyword before a function using await. That is something that I have definitely encountered when I first learned about async await. So I feel like this is something that should always be considered. And then another error is that not the await should always be wrapped up in a try catch block for error handling. And then there's another mistake that could be like forgetting to return inside a then chain, which would break a sequence. Some key takeaways for here is that JavaScript's async behavior keeps apps non-blocking and responsive. Promises are objects that represent future values, and they simplify the async flow. And then for the methods, you should use then for success, catch for errors, and finally for cleanup. And then async await always provides a cleaner, more readable syntax for promises. And then in order to practice such async await programs, we you could always try to practice it with real APIs like JSON placeholder or the weather API to see these concepts in action. Once you're comfortable, you can even go try to explore the Promise.all method for running multiple asyncs in parallel. So I think that covers the theory we had. So, does anybody have any questions so far? Okay, so now that we have covered, hold on, let me just take the attendance real quick. Okay, so now that we've covered the theory, I'm just going to switch over to the live coding demo that I planned, and we're just gonna build out see some of these concepts step by step, starting with creating our first promise. So let's share our screen again. Okay, all right. Can you guys see my screen?
Yep, we see VS Code. Thank you.
Okay, so this is just okay. So here's so I just wanted to walk you through the setup. I've just created a simple HTML a page which for our async JavaScript demo. It just has an input field where we can enter a user ID. The button would fetch the that user's profile, and then there would be a div at the with the ID output, which is where we will discover results. And so, and then this is the common style. And if I just run this particular website now, shouldn't I should be running anything. As you can see, this is just a normal form where we will just enter the user ID, and the details would get fetched based on the given data. So let's just start with our JavaScript. So right here, what I've done is I've just created a small database using JavaScript objects. This will definitely this will help us focus on understanding form promises first. So I've just created this particular small data set which consists of users with their subsequent data and the posts that they have added. So we're just going to be moving on to creating our first ever promise. So let's just create our first promise base function, which would simulate fetching a user from this database. We'll just call it fetch user. So this would be our function called fetch user, which would take the parameters of user ID and just return a new promise. Now, of course, they would definitely have the resolve reject parameters. And then there will be our function, is a promise function here, which would set our, we just wanted to, show out a particular delay because whenever you're simulating API calls in real life, you will never get it like immediately. So that is why you have to simulate some sort of timeout. For here, I'll just say let's keep it 1,000. That's just basically 1 second. And then I would just try to find the users based on user ID. And if there is such a user, it will return us the user using the resolve method, or else it would give us the failure. So and with this reject, I'm just sending out one message called user not found. And always be careful to make sure that all parentheses and the all the colons are closed. So it would just take it. So I'm just gonna take a few moments and try to test this out. This was not okay. So we're just gonna test this out in our console right here. So if I type out fetch user1, it should return us a value. Oh, wait. Save the changes. Okay, let's try to refresh that. Uh, okay, so oh, okay. So the script tag here was a bit undefined, so that's why we were getting that particular error. And now I try to reload that. And we should be getting our particular user. So if I look for user1, it returns a promise object, which should have all our particular data. And then if I try to look for user, say, let's say user number 69. So that would still return a promise, but it wouldn't have any data inside it. So yeah. So I hope that was a bit clear. Okay, so now that our first promise is running, let's try to create a new one, which is called fetch user post. The functionality would pretty much be the same. And instead of fetching the user, it would just fetch the posts that have been created by the user. So the syntax would probably remain the same. Always make sure that the parentheses and everything is closed. Just get the posts right here from our user post list based on user ID. Then if anything has been found, then the resolve method will be in place, or else it would be the reject method saying no posts found for this user. So it's just like before, we would return a promise, and inside we would simulate a 1 second delay. So if this particular user has posts, we would resolve that with the array, or else we would reject it with an error message. So let's see if it has worked. This was the earlier method. Okay. User posts, and let's look for user one. Oh, user. Oh, okay. I think I see my error there. Meanings was a bit wrong. Always make sure that your references are correct. That's why we were not able to see anything. Okay, so after referencing the right object, this is what the user would actually look like. And upon adding of pending user, you can see how it's just showing that the user is not found. And then once we fetch the user post for a particular existing profile. Oh, okay. I had to update this. Okay, so you can see that the first user had the following posts right here in line 9. So that is what's been showed. And upon failure, I think the same result would be coming up. So now that both promises work individually, let's try to chain them together and see how we would first try to fetch the first user, and then we would try to take a look at how does this even go. Uh, okay, so now that both our promises work perfectly, let's add a third promise that would process those posts and return the total count. We'll just call it post count. Uh, but instead of doing that, we could always resolve with its length instead of the array. And I think that would do the same. So just copy this particular function instead of the post length post array, we just be passing the posts, the number of posts that a particular user has. Let's call this post count. And then once we are able to write it down in our console, you can see that this particular user has the posts, and after a second, oh, this was the fetch user post. So we just needed the post count. So the first user had about like 3 posts. So that is how you can see that the first user can just this one's really simple. It's just all it would always resolve. There would be no rejection here. It would just take the user ID and it would return the count after 1 second. If there's no such user, then there would not be. So let's just try to chain them together. And now this is where it might get a bit complex. So this would be our fetch. We'll just be calling this our fetch user. And then it would have a then method. So if the user has been able, so if the user number one gets fetched, so this is what it would do. We will just write user found. We would try to that by in different quotes. Just reference the fetch post count for that particular user ID. Third, to see uh, what would be once the user has been found, we could use to get the particular posts under their under for that particular user. And then once we do that, just a simple console.log statement just to see if the posts have been found. This is also another way to reference the variables in case you haven't seen this. And then we would just return the number of posts. Count. And there is also another then method which would just count that particular number of posts, and it would just return the number of posts that are there. So this is one small change that was needed just so this uh, just so this works. So as you can see, each then state method would wait for the previous step to finish, and then if any step fails, then the catch method, which would be written here, would catch any errors if found, and then the finally method, which will be defined later, can be used to clean up any existing references. Parameters are passed. We can just simply put two empty brackets just to signify that. And this would just be a simple process console log statement where we would just say process complete. So each then would, as I said before, each then would wait for the previous step to finish. And then if any step fails, the catch method would handle it. And then the finally method would always run at the end. It's really perfect for cleanup and or the UI reset. So let's try testing this in the console. You can see that each step would appear 1 second apart if this goes well. So let's try testing that.
Meet, can we stop you for a second, actually?
Sure.
There was a question in the chat. Were you able to see that?
Um. Okay. If I want to fetch multiple users and their post, would we need to chain for each particular user, or can we do it in parallel? So in this particular, this is actually a good question. So if you wanted to fetch multiple users and their posts, you don't really have to chain for each one. That would make the operations on sequentially, which would be slower. So instead, you could just run them in parallel using Promise.all. So Promise.all would take an array of promises and it would wait for all of them to complete. And then I would try to explore it if we have some time at the end. So that way you would also get to understand how we can fetch data for multiple users as well. So let's try to test this particular example. Okay. Okay, so you can see that our particular code has been run successfully, and since the delay was about like 1 second, we were not able to see that particular see how each and every example was done. So that way, so once you adjust the delay count to maybe something more than 1,000, like uh let's say 2,000 or maybe 3,000, you would actually see how that particular chain has been executed. So let's try to convert this particular example to our async await, how this would look in async await. So let's try to convert this same particular logic into the async await function. You'll see that it does the exact same thing, but the syntax would be much cleaner, and you can also try to and then reading would be much easier. So what I'm going to do is, instead of the constant thens, I'm just going to try and all the details that we can. We're just using the uh, defined promise functions that we had defined earlier. And then the console log systems would be the same. Let's try to change the message of it so that you can see how different the names would be. And then we will take a look at the posts, which would be defined by the await function. And let's see what's the fetch user posts. That would be based on our user ID. Say that once the posts are found, you have so and so posts, and then once the posts have been found, we're just going to use that to fetch the current post count. That would be based on posts. And then another console log statement just so we can see. Okay, so once this strike clock has been defined, we can just define the error block. That's the that could be used to figure out what could be wrong. And then there would be one finally block, which would be process done. So here, so let's try to run this. And this time I'm going to try to set the delay to maybe 2 seconds so that we can see the differences in both. Okay, so this is how the first promise was run. And since we haven't really called this function, so now you can see that since both our blocks are working, so the async await implementation is working exactly as intended. The sequence of logs show that the awaited promise is resolving in order with the final cleanup running afterwards. And then what we can do is I would like to get your opinion on something. Either I could try to show this with the real API, or like Johan asked, I could show what we can do to fetch multiple users. So I would like to get your opinion on this. What do you think I should do?
Do you have any opinion on what you think would be more useful to us as like beginners?
Yes, that is what I am asking. So if you want, I could show how we can fetch multiple users and their posts, or I could even show how we can use a real API to how we can fetch data from a real API. Of course, that is one of the topics that will be covered in the next week's session. But I just wanted to get your opinions on this particular thing.
I'm ambivalent, but thank you.
How about the others? What? So
I
since
do like
we'll
the
be
multiple users thing. Sorry, go ahead.
yes, so yeah, that's what I was thinking too. Yeah, so I'm just gonna show what it would be like to fetch multiple users in a single function. So I'm just gonna go ahead and completely comment this out so that we do not have any more ambiguities. So let's try to see how we could fetch multiple users and their posts in parallel. So instead of waiting for one user to finish before starting the next, we will use the Promise.all function to run all those. And here's how it would go. Let me just define it. And it would be something called show multiple users. And then our users would be user IDs. And then this would be a here is we would take an array of user IDs and we would map each one to an async function that would fetch the user, their posts, and the post count. And then promise.all would run all those promises in parallel and wait until they're all done. So, in the event if anyone fails, the catch block would handle it. So, just give me a few moments while I try to code this up. And do not worry about the coding examples. These will be available to you on my GitHub repo. I will be posting a link to that once our session has after the at the end of the session. This is the ID. These are the posts, and these are the count of that particular post. And then we would return those in the form of an object. Then once we get that, let's just try to put them up in something called in this variable called results, which would use the promise.all function to get these user promises. And then we could just put it up in a console.log, which would just show users and their post counts, which would be results, which would also come from results. And as always, with every try block, there should be a catch block as well. The, the finally block is completely optional, but the catch block is something that you cannot ignore at all. This is often used to handle exceptions, and whenever you end up working in tech, you will see that most of the services are bound by code like this. And you should always make sure that the error messages are really clear. And then this would be our final block. Let's come this. Okay. I hope. Okay, I really appreciate your patience on this. I do realize that we have gone a bit out of clock. So let's try to implement this. And let's see what happens when all the users are added. So let's try to test that. I hope you're excited for this. As you can see, we just got our particular promises which have been fetched for all particular users. So this is how you can fetch user data for multiple users at once. And it's just the statement at the end just proves that all three user fetches ran in parallel, and the results were collected once all the promises were resolved. So let's try to see what happens if I add a user that does not exist. So in that case, what would happen is that the error would be thrown just because one of the users aren't existing. But the cleaner statement here would indicate that this particular program has run. But for this particular function, we just had to make sure that all the users that were being passed were completely legit. So that is how you can fetch user data for uh, multiple users. So let me just stop the recording right here.